Over the coming days and weeks, I'll be documenting the build of the new 3D printer, so you'll be able to see all my successes and all my failures as I progress throughout the build. To start off with, in this first build video, we'll be talking about the X-axis and the X-carriage, and also the bronze bushings that I've purchased to accompany the aluminium rods. As stated previously, one of the design goals with this 3D printer is to keep the moving mass as light as possible. And as the X-axis and the whole Gantry will be moving on the Core XY design, that means I need to lighten up the rails. So instead of using steel, I'll be using aluminium tubing. That also means I can no longer use the LMU style bearings, which isn't a bad thing because these are notorious for A, being loud, and B, for cutting grooves in your steel rods. But what is great about these bearings, and I guess we've been spoilt, well, I've been spoilt since using these from day one, is they have a great tendency to self-align themselves if the rails aren't perfectly aligned. They just seem to absorb any misalignment. Whereas these bronze bushings, even though they're quiet on the rails, any hint of misalignment causes these to start to bind and stick, which is something that I haven't experienced before with the LM8 UU bearing here. But as I'm moving to aluminium, I can't use the linear ball bearings because the bearings will cut a groove into the aluminium way faster than they do into the steel rods. So let's have a look at these bronze bushings. A YouTuber by the name of Christian T has brought up a great comment in the previous video. He reckons that his Chinese brass bushings allow magnets to stick to them. Well, here's a magnet, and it sticks to this so-called brass bushing. Having a look at the eBay listing, even though it's titled as brass bushing, looking further down, the material is actually low carbon steel plus oil impregnated bronze, with an appearance of being copper plated. And that's more descriptive of what these actually are. But end of the day, as long as these provide the service that I'm after, that's all I care about. The first design consideration with the Core XY is the X gantry and the two rails for the X-axis. Will I mount them horizontally or do I mount them vertically? Well, looking back at the Prusa i3, the one that I have has the rails vertically like this, and the quality of the X-axis on the parts that my Prusa prints is perfect. There are no oscillations or ripples on the X-axis. The walls are perfectly straight, so I think I'll keep with the vertically aligned rails. This also allows the shape of the Core XY frame to be rectangular because it doesn't have to be so wide. I can actually gain some space in the Y-axis. So I know these linear bearings move up and down the aluminium rods very smoothly. There's no problem with that at all. The next step was to actually design the X-carriage, and knowing that my X-carriage is going to have the rods vertically stacked, I've gone ahead and designed the X-carriage itself, and this is a similar design to the Prusa i3 X-carriage that I currently have, which has the two bearings at the top and bottom, and also the flat surface on the front to allow the E3D mount to attach to. The problem with having these two bearings just cable tied in here like that is there's no guarantee that they're going to be perfectly aligned. Sometimes they will be, sometimes they won't be. And just to demonstrate that, if I move this up and down the rail, sometimes it'll bind, sometimes it'll move freely. So this is going to be inconsistent with the movements of the printing. And the other problem of having two sets of bearings stacked vertically like this is if I now move this X-carriage to the X-gantry itself, slide that in, put the other side of the XY joiner on there, get that in there, just a tight fit. Now all of a sudden, this is way tighter again. There's no way that's going to be sliding on its own with gravity. Just the fact that the two rails may not be perfectly aligned is more than enough to have these linear bushings bind full time. So this particular setup is not going to work at all. So there's two problems with this design. The first is there's no guarantee that both of these bushings will be perfectly aligned on each individual rail. And the second problem is there's no guarantee that both of the rails will be perfectly aligned. to tackle the first problem, it was clear to me that the bushings needed to be fully constrained to be aligned on the rail. And this design here seems to work just fine. This is just a cylinder with 2 of these bushings inserted in each side. And this is a tight fit for the bushings. If I grab a rail and just show you how this slides nicely, there's no binding whatsoever. It's sliding as if it was just one bushing. So this is the fix for the first problem. And for the second problem, where the alignment between the rails may not be perfectly aligned, reading online, it seems like we need one of these rails to be called a guide rail. So that's where the double bearing will sit on. And the other rail will be called a floating rail. So we need a single bearing on the bottom of the X-carriage with an ability to potentially swivel ever so slightly like this, and maybe even move or slide up and down just by a very small amount. So this design here just has one bearing. It's clamped onto the X-carriage with a nylock nut. It's not allowing any movement in this direction whatsoever, or in this direction whatsoever. It's only allowed to swivel like this and move ever so slightly up and down like that. So using our constrained bearings on the top, fixing that on the top and having the floating rail on the bottom, I'll show you what that does. And here is the final design for the X-axis. We have the 2 bearings constrained at the top on the guide rail, and we have the single bearing floating on this bottom rail. And this moves really smoothly on the X-gantry. It even moves with gravity. So I don't think that's going to be an issue for me moving forward. Obviously, time will tell if this floating bearing has any impact on the finished print quality. But just looking at the way that this carriage sits, there's next to no play on this carriage. The only play that there is the tiny gap within the bearings themselves. So hopefully, this is going to work out just fine. I'm interested to hear from you. Do you think this will work? Do you think this won't work? Have you tried this before? Have you had any success? Have you had any failures setting up an axis in this particular way? Let me know in the comments below, and thanks for watching.